Cold countries need a lot of energy, and Canada's no exception. But we use too much, twice as much per capita as Sweden. And in a world where energy efficiency is becoming a matter of survival, something is going to have to change. As things now stand, these are our energy needs. A good 50% is required for low-temperature heat. 1/3 for transportation. 1/12 for high-temperature industrial heat. 1/14 for pipelines and industrial motors. And if electricity were used only when it's most efficient and when there's no other alternative, it would represent 1/25 of the total. When energy costs go up, people suffer, and the evidence isn't hard to find. This empty shell was once a greenhouse, but it got too expensive to heat. The problem is basically this: how to replace fossil fuels with energy that's renewable and that's more easily available. In Prince Edward Island, they're working on some answers. The costs for fossil fuels in PEI are among the highest in the country, and all of the island's electricity comes from these same fuels. This means that energy costs can be crippling, and that future shortages could have disastrous consequences. No region of the country is immune from this danger, but since the island is particularly vulnerable, it's actively seeking local and renewable sources of energy. Andy Wells is director of PEI's Institute of Man and Resources. The institute has been set up by the government to study the practical application of renewable energy. In a way, Andy's research begins in his own home, where he lives with his wife Lynn and their children. The house is well insulated, and it's designed to get the maximum benefit from the sun's heat. Wood is the main source of fuel, and in most respects, the family's daily life is remarkably self-sufficient.
All the experts so far are saying renewable resources don't come in as cheap as the big conventional energy systems.
Sure, it's expensive now to do certain things because each and every one of these various things are almost custom built. Oil furnaces, when they first came out, were very expensive. But they're a dime a dozen now because they're churned out on a regular basis on an assembly line. And the same thing will happen with solar collectors. The same thing's going to happen with windmills eventually.
The question remains: can renewable energy do enough for us? And can it be adapted to urban needs? Out at Spry Point, there's an experimental bioshelter called the Ark. It's been designed to provide shelter, heat, food, and electricity for a family in a northern climate using natural systems only. The translucent paneling of the greenhouse and the solar collectors above them bring the sun's heat into the building where it can be stored until needed. About 1/3 of the Ark is a home. The rest of the structure consists of a commercial-sized greenhouse, a fish farm, a barn, and a laboratory. The windmill is a prototype being tested at Spry Point. It transfers the wind's energy hydraulically to a generator below. Eventually, when it's fully operational, its surplus electricity will be fed into the province's power grid. The Ark is a creation of the new alchemists who were invited to the island on the basis of their earlier work by the provincial government. Unlike most living spaces, it creates energy and provides food instead of squandering both. It's also a source of interest and information for the entire island and welcomes visitors once a week on Sunday afternoons.
Hi, Nancy.
Hi.
This is my son, Billy.
Hi, Billy. I'm Nancy. Come on in.
Mr. Van Kampen has come from Charlottetown for advice. Forced to close all but 2 of his commercial greenhouses in the winter, he's consulting Nancy Willis of the New Alchemists. He plans to build a new greenhouse, and he's looking for ways to conserve the sun's heat and cut down on fuel costs.
Now, this is the most interesting side.
You like this too better than the other
Can you
part,
feel
eh?
the difference here in the temperature immediately dropping?
It's not hard to notice that.
What's happening is the heat source in this greenhouse is solely the sun coming in through the glazing up here and collecting in the duct up there, which is a natural area of design, which just holds the heat.
Yeah.
And it's drawn down that galvanized tube there with a
suck it
fan
off.
that is constantly running, just very slowly running and drawing it down through. Then it draws it over a rock storage bed. The rocks pick up the heat, and the cooler air is shunted out these vents right here. Then the same process is continuing in the nighttime. Nothing is changing, except, of course, the temperature of the air and the gable is changed. The temperature is cooler now, and it's drawn by the same fan in the same direction, passing over the rocks. The rocks, which are then warmer than the air, allow the air to pick up the heat from then, and it is shunted out again here in the night and heating the greenhouse at night. And I believe the lowest we've gone has been 45 degrees Fahrenheit at night.
For what you're growing, that's quite
Vegetable,
acceptable.
Oh, absolutely perfect.
What I would like to do is get a system that would heat a greenhouse to 60, 62, or guarantee a 60-degree temperature.
I would assume that you would then go into a certain amount of shutters, which at night would eliminate your maximum heat loss.
The greenhouse provides fresh vegetables the year round, with a surplus which can be sold on the local market. In addition, hundreds of tree seedlings have been started as part of a long-term reforestation project. Lizards, ladybugs, newts, and a snake keep insects under control. There's no need for pesticides. The algae ponds retain heat within the greenhouse, stabilizing the temperature, and the algae feed the fish, which can then be marketed. All the systems are monitored by instrument and provide reliable scientific data. Organic garbage makes a valuable contribution to the Ark. Vegetable peelings and wastes, composted in the Clivus Multrum toilet, are a source of sterilized fertilizer for the gardens. Water from the solar collectors is stored in tanks under the living room floor and provides the basis for a forced air heating system. The only additional source of heat is a small wood stove. The Ark attracts so many visitors that it can be a problem just to look after them. Professor Frank Hooper, one of Canada's foremost solar engineers, has come to see the Ark and to talk with Nancy Willis and David Birkmark, one of the architects who designed the structure.
It really is going, isn't it?
It's blowing pretty hard.
Richard Thomas is a freelance broadcaster from rural Ontario who brings questions from another perspective.
Hear about that.
What I'm talking about is how the people I represent, the people I live with, would look at this. They'd come in, it's snowing outside, it's cold, the wind is howling up somewhere near 90 kilometers an hour, and there's snow accumulating on those things and falling off every so often. But as far as I know, there's a little wood burning over there. There's 1,800 square feet, and there's flowers growing. They want it. How long are they going to have to wait?
The first thing you can do is you can build your house as a heat trap, okay? What you do is you build a house which is insulated, which has the ability to be closed up and to lose very little heat.
Well, I'm still trying to look at a house I'm building, and I'm seeing my materials, and you're talking in abstract here.
Okay, well,
okay, I've built my house, right? And Nancy just told me that my house becomes the collector. The only thing I can think of is I have my windows facing south,
Right.
and as soon as the sun goes down, I wrap big pieces of insulation down over my windows. Is that it? That's,
Right, but the other thing...
Very good beginning, but if you're also talking about putting a fireplace into your house, for instance, or a stone flue of some kind, put it in a place where when the sun does come in through your south-facing windows, it hits the fireplace. And through the evening, it'll radiate that heat back out again.
What we have learned from this building this winter is that with proper design, with functional design, in terms of what we've just been discussing, almost any energy source that you use to heat the building, any energy source, becomes auxiliary heating system.
Many individuals are applying these concepts in their own homes. Should they run into problems, they consult Bill Zimmerman, an engineer with the Institute of Man and Resources, who provides advice on energy projects.
Mr. Wheatley. Yes. Bill Zimmerman from the Institute. Good to meet you.
Bill Wheatley has installed solar collectors to heat his domestic hot water and has asked the Institute for some help.
Yes, we're just trying it out, not finished yet.
The technique is simple. The sun's heat is collected on the roof by a homemade solar collector consisting of copper tubing soldered to metal panels and covered over with plastic.
Let's take a look at what you've got inside now.
Yes.
A pump in the Wheatley's basement sends cold water to the roof through the collectors and returns it heated for storage in the tank.
600 gallons worth of storage in there.
That's right, and it's fiberglass line.
The whole project cost Bill Wheatley $700.
See, this is the line, is this the line, the return line from the
return line,
collector
yeah.
upstairs? And then the pump is...
The Wheatleys were among the first. But since then, many more families have installed solar collectors for their hot water.
coming back down.
For 5 years now, the Ramsays have been harnessing the wind to furnish all their electrical needs.
On a windy day, for example, you could have every light in the house on and everything else and still be putting a positive charge into the system.
So even though the windmill out there is turning right now, it's not really generating any electricity.
No, that's less than an 8-mile-an-hour wind. You have to have a minimum of 8 to
But
charge.
in other words, with these batteries, you don't really have to worry about those calm periods. You can still operate the house just as if the wind were blowing.
Oh, yeah, definitely. We've gone as long as 27 days here. And I used to have an auxiliary backup generator that I had tied into the system, but I've never had to use it because we've always managed to wind come up before the system ever got down.
If you use, say, 200 kilowatt hours a month, you've got almost a third of your month just stored in the batteries.
Stored in the batteries, right. But, I mean, you can always expect, at least in this country, to have some kind of energy input once every 3 days or so, and that's a significant energy wind input. Mm-hmm. It's just a question of the priority use for electricity. I mean, lights, you need electricity for that. All of your basic services like pumping water, like toasting your toast, vacuuming, your entertainment, your stereo and the TV and all that sort of thing. These things really don't use that much electricity.
The system you have here, how much of the money goes into the batteries and how much into the windmill and the tower and into the
Okay,
controls?
right now, the cost of the entire system, which would include the plant, the tower, 40-foot tower, the battery storage pack, the control panel, is in the vicinity of $7,200, and your batteries out of that are about $1,600 worth. You have the self-sufficiency with the batteries.
Right, and otherwise, you here aren't connected to the power system at all.
Not in any way, no.
Independent from
Right.
the electrical grid.
The Institute of Managed Resources is in constant touch with the provincial government.
The individual homeowner has to borrow money at mortgage rates if he wants to put one of these improvements in his home. Whereas if a public utility in general wants to go out and get money to finance a power plant to provide the same amount of energy, they get much more beneficial financial terms. What's the chance of the government essentially saying, well, what that person wants to do is just as desirable to the overall energy situation as what the corporation wants to do? Is there some way that we can give them that same kind of financial leverage? Is there a chance the government can get involved in that way?
Well, I really think that it's a very exciting proposition. There is yet no program in place for this, but certainly as governments are prepared to go out onto the bond market to buy generators and to buy transmission lines and power cables and the like, we must be willing as well to provide the kinds of capital that might reduce the need for imported oil or imported electricity.
The Institute has also been investigating wood and its potential as an energy source. It could provide electricity on an island which has few rivers to dam, but which is half covered in forest. The original PEI forest has been degraded over the centuries through overcutting the best species. If it were cleared out and replaced with quality seedlings, it could generate heat as well as electricity, the land would be renewed, and the woodlots themselves would again be economically viable.
What's happened in the past is the idea of you go to the woods and there's something there to go to. Yes. And then you wait till there's something to go back to. Well, that's a long, long process, a slow process. Yeah. Well, it's been cut over about 40, 50 years ago, and it just seems to develop into this stage and then it'll blow out. It never seems to develop into anything much bigger than this. There was some pine.
At one time, you cut a lot of pine out of here, though.
Well,
didn't you?
years back, before my time, there was pine in this area. Yeah. But
What use is it as it is?
Not too much.
This 100-acre block of land with just very extensive forest management inputs should be producing somewhere in the vicinity of $6,000 a year worth of fiber to Charlie. Instead, Charlie is sitting on this block of land and he pays the taxes on it and he can't use it. If we can cut it down and Charlie can sort out the valuable material for logs or local lumber that he has markets for, then he can sell the rest of it as a fuel.
And I think where the government comes in is probably twofold, is to promote and to encourage and to financially set up wood-burning operations to generate electricity, which is something we need, and at the same time, of course, to come in with a very strong forest management and reforestation program.
Someday, Charlie Cook's woodlot and sawmill will provide energy for many other islanders. Already, he's putting a byproduct from his mill to good use. By adding a sawdust burner to his standard oil furnace, he can now heat his whole house with a product many still consider to be a nuisance.
Nice red spruce dumped in here. You know, it really smells lovely.
But not everyone owns a house, and not everyone lives in the country. If we want to reduce our dependency on imported fuel, renewable energy must be put to work in the city. It's being done in a large-scale redevelopment project on Charlottetown's harbor front. 15 historic buildings are being restored and brought up to high insulation standards, and 25 new buildings will be integrated into the area. All buildings will be designed to use renewable energy through a central heating system, when oil heating prices warrant the switch.
Now, the obvious question then is solar heating for a project of this scale is something I personally have never seen, and I don't know where such a thing might exist. Are we breaking ground that is dangerous for us given the practical constraints we have?
I think we are breaking ground in terms of the concept. In order to use solar energy as a means of heating this complex, one has to have a heating system that can utilize quite low temperature water, because solar heating systems, solar collectors, are inefficient if they have to collect heat at high temperatures. And so we are proposing to have the system built to utilize 100-degree Fahrenheit water as the heating medium. And now we will heat that water generally at the beginning of the project with oil. And only a small percentage of that heating will be by solar. But as the years go on, we'll install more and more solar collectors.
This project is going to consume a lot of energy, and we are in the business of revitalizing the core area of Charlottetown, and in the process of it, we have to create places where people can work and live and not be priced right out of house and home by energy costs. And as the promoter or developer, it's important to us that in 20 years' time, we are going to be able to afford to have people live there.
Could you feel justified in not doing that, Fred, in saying we can't afford it this time?
Well, you know, I suppose right at this time it'd be awfully easy to say that, you know, bother with it, but a person would have a lot to answer for in 10 years' time when oil's $1 a gallon or something, you know.
How about your engineering colleagues, Dennis? Are they going to look at this with skepticism?
Well,
or?
no. I think that, you know, I'm a consultant, and I work with things that have been known and are proven. We are aware of these things that are new. We read the literature, but we never get a chance to really use them until they're proven. From an engineering point of view, it's pioneering.
Is the scale of Charlottetown such that it makes it much easier to do it here?
No, it is only a level of awareness in Prince Edward Island that makes it more possible to do this sort of thing here than elsewhere.
Well, Andy was talking about us 30, 40, and Frank, 30, 40, or 50 years from now, I had this little fantasy. I was seeing us all aging and aging and aging, and I guess I'd drop off first, and some of you might survive that 30 years. And there you sat with your long gray beards, and still warm and comfortable in this house with the energy which is being used now. And I wondered what the need is for the nuclear energy, what the need is for the fusion energy.
If we continue to spend vast quantities of our social capital in encouraging and fostering and developing the few non-renewable resources we have left, such as the Mackenzie Valley Pipeline, such as nuclear power, such as tar sands, that we will have bankrupt ourselves in the sense of using up our available social capital in these developments. The goal always is that 50 years from now, we will put Canada in a position where what we have available to us on a regenerating basis, on a renewable basis, will be sufficient to allow us to function. I've been persuaded by the arguments, by the figures, by the discussions that it is certainly possible for this country to live quite comfortably on our renewable resources if we make that commitment now.